resolution, if you remember.
Yeah.
Now, in high resolution spectroscopy, the peaks, so normally if you have a graph, then at certain values, of chemical shift, you can expect some peaks, like some peaks like this, maybe some large peaks, some small peaks, a combination of peaks like that. So this is what
Yeah.
we get in low resolution NMR. In low resolution NMR, you only get the peaks. However, with high resolution NMR, what happens? The peaks can be split. So the peaks show you some splitting patterns. That is, a peak can behave like this, or it could be two very thin peaks together. All right. So you can see some
All right.
examples here. So each type of splitting has a name. All right. For example, if
Yeah.
you only get a single line, we call that singlet. We call that a singlet because your graph or your
Yeah.
spectrum only has a single peak. And thus, you can also get two peaks together, very close to each other. We call that a doublet, and then triplet, quartet, quintlet, and so on and so on. Usually, we don't need more than you don't need to know more than quartet or anything. They won't ask you too much. So we'll look at some examples today from the question paper, some examples of some questions.
All right.
Before that, I'd like to show you first example first, and then we'll discuss some questions relating to NMR spectroscopy from the question. That will probably help. Now, you have to notice something here that each type of pattern, all right, each specific
All
type of
right.
pattern, the peaks, they have a certain pattern in them. For example, if you look at doublet here, in doublet you get two peaks together, right? And you can see here
Yeah.
that they have the same size, like the peaks, individual peaks are similar height. This height is like same. Yes or no?
Yes.
Like both. So this peak and this peak, they're having the same height, which is why the relative size is 1:1. Do we understand that? Why is the relative size 1:1? Because their heights are same. That's why. Okay. But
Yeah.
if you look at the triplet pattern, what can we see in the triplet pattern? There are three individual peaks, right? Three smaller peaks.
Yes.
Now the three peaks are not of the same height. That's what's important. You have to remember this. So out of the three peaks, the ratio of the heights is 1:2:1. That means the one in the middle has a ratio of 2, which means it's slightly bigger. It's slightly larger than the other two. All right.
Yes.
And then in quartet, again, the pattern is slightly different. The ones in the middle, the two peaks in the middle, they're of the same height, but they're taller than the ones on the edges. All right, and so on and
Yeah.
so on. So again, don't have to memorize them. You will slowly, get used to them as we do question paper in the future. But you don't have to memorize the graphs or anything. All right. So
All right.
let's look at some examples first for high resolution NMR. So I'll just try with some compounds, some simple compounds first, and then we'll go to the question paper. So this is a very simple compound. It's an alkene. It's what? Ethene, right? It's
Yes.
an ethene. Now, remember, when we're doing proton NMR, remember, this is proton NMR. So I think we remembered that when we do NMR, for NMR spectroscopy, you can either target a carbon atom or a hydrogen atom, right? We talked
All
about
right.
carbon-13 NMR before, remember?
Yes.
Now, proton NMR specifically targets hydrogen. Now, in this compound that I've drawn here, you can see hydrogen or not? Do you see nitrogen? Sorry, hydrogen. There are hydrogens, right? 4 hydrogens.
Yes.
Now, it's important to understand that their environment. So think about the hydrogens. So let's say this is hydrogen 1, hydrogen 2, hydrogen 3, and hydrogen 4. So there's 4 individual hydrogen. Now, can you tell me if you think that the environment of each hydrogen atom is same or different?
Um. Same.
It's same actually. So each
Yeah.
individual hydrogen, they have the same surrounding, right? So we
Yes.
can agree that all hydrogen atoms have the same chemical environment. Now, if that is the case, how many peaks do you expect in the NMR spectrum? How many peaks can we expect? We can only expect one peak, all right, or one signal. One
All right.
signal or one peak. Why one? Because there's only one chemical environment. That's Does that make sense?
Yeah.
All right. Now, remember, since this is high resolution NMR, the peak or the single is not a single peak actually. It's actually splitted, right? It actually shows in terms of like it's not a simple graph or simple peak. It can either be a singlet, doublet, triplet, quartet, or quintlet. All right. Now we have
All
to
right.
figure out which of these is possible. So consider the hydrogen atoms, okay? Consider the hydrogen atoms. Um, so here, whenever we are trying to figure out the number of peaks, we have to follow this rule called the n plus 1 rule. Now, when you want to follow the n plus 1 rule, here, the value n that we place, this is important to understand that what actually is n. Now,
All
n
right.
is the number of hydrogen atoms in or on the next on the next door non-equivalent non-equivalent or number of, not number of atoms, or number of, let's just say number of, is the number of next door non-equivalent hydrogen atoms. All right, so now what does this actually mean? Now what does this actually mean? So in this compound that I've drawn, okay, let's focus on a single hydrogen at first. So let's say let's focus on this hydrogen, okay.
All right.
Now this hydrogen is attached to this carbon here, right?
Yeah.
Now who is the neighbor of this carbon atom? The neighbor of this carbon atom is this
The
carbon atom.
yeah.
And that carbon atom has how many hydrogen atoms?
Two hydrogen atoms.
Two hydrogen atoms. Now here's the tricky part. You have to understand that compared to this hydrogen, right? The hydrogen that I have
Yes.
circled in green, compared to that, do you think that these neighboring hydrogen atoms have same environment or are they different environment? So hydrogen 1, okay?
All
And
right.
the neighbor hydrogen atoms are hydrogen 3 and hydrogen 4, right? These are the
Yes.
neighboring hydrogen atoms. Now I want you to tell me whether hydrogen 1 and hydrogen 3 and 4, do they have same environment or different environment?
They
Chemical
have
environment.
they have same
Yeah,
environment.
they have the same environment. Do we? Yes, that is correct. So we are clear on this, right?
Yeah.
Are we 100% sure about this? Not
Yeah.
really.
Yeah.
Okay. Now, since they have the same environment, that means they are equivalent or they are the same. That's how you will perceive them. All right. Because they have the same environment, they will be equivalent. Is that fine? We call them equivalent. However,
Yeah.
in
Yeah.
this formula, the value of n that you're supposed to put is only specific to non-equivalent hydrogen atoms. When I say
Yes.
non-equivalent, that means the other hydrogen atoms must have a different chemical environment. But in this compound, that is not true, right? You don't have
Yeah.
other hydrogen atoms with different environment because they all have the same chemical environment. Can we agree on this?
Yes.
That means the value of n in this specific compound is 0. So if you do n plus 1, which is 0 plus 1, you'll get 1 only, right?
Yes.
Since the value of n plus 1 is actually 1, this value is actually 1, you will say that the number of splitting peaks will be 1, which is respective to what pattern? Singlet. Do we understand?
Yes.
Okay. Which means for this compound, if you actually try to do NMR spectroscopy, you would make a graph, or you would get a graph which only had one large peak, only one peak. It would not have any splitting patterns because it would follow the singlet rule, singlet pattern. And for singlet, the appearance would be like this, only one single peak. Is that fine?
Right. Yes.
All right. Now all the hydrogen atoms are actually same, right? Similar to the like carbon hydrogen number one, because they all are identical
Yes.
chemical environment. So I'm not going to have to do the calculation again and again, okay? Because I know that for each of them it will be singlet itself. For each hydrogen atom it will be singlet only. So there is no need to do any more calculation. So this will be singlet. So this was first example. We'll look at a couple of more examples. Let's say this one. This is an alkane. I think this is ethane, right? It's ethane.
Yes.
And you have a lot of hydrogens. So hydrogen atom one. I'm just going to label them just so that you can understand, because I'm not in front of you. So just so that I can point out which hydrogen I'm speaking about, that is why I'm labeling them. There is no, like, it's not a requirement to label hydrogen atoms. Okay. I'm just labeling them so that I can
Yes.
explain to you. So we have 6 hydrogen atoms. Now again, I will ask you again. So do you think that each of the hydrogen atoms have the same chemical environment or different chemical environment? What do you think?
They have the same chemical environment.
Same chemical environment. All right. So now let's just look at any specific hydrogen atom in particular. All right. Anyone?
Right.
Would you like to choose which hydrogen atom would you like to like specifically look at? Choose. It's your wish.
We can choose hydrogen number one.
Okay. Now in this specific compound, it wouldn't matter because they all have the same chemical environment. So you can actually choose anyone. Anyway, so let's do n+1 rule. Now, when I try to do n+1 rule, the question is what should be the value of n, right? That's the big question. What should be the value
Yeah.
of n? Now consider hydrogen 1. The hydrogen 1 is joined to this carbon atom, right?
Yes.
And who is the neighbor of this carbon atom? This is the neighbor of that carbon atom.
Yeah.
And that carbon atom has how many hydrogens? 3 different hydrogen atoms.
Uh, yes.
Now, I want you to tell me whether hydrogen 1 and hydrogen 3, hydrogen 4, and hydrogen 6, what do you think about their chemical surrounding or their chemical environment? Do they have the same chemical environment or different chemical environment?
They have the same chemical environment.
So your value of n will be 0 because unfortunately they're same chemical environment, so you cannot consider them in the value of n. So again, here
All right.
also the value of n+1 is 1, so we can expect that the splitting pattern will be singlet, similar to the one before. Is
Yeah.
that fine? Okay. Try to look at a bit different examples. Um, So this is an halogen alkane. It's a chlorobluoro. I think it's a bromochloroethane. That's the name. There's a bromine group. And anyway, so again, there's different hydrogen atoms here. So let's label them 1, 2, 3, 4. Okay. Can you talk to me about the chemical environment? Whether you think there are hydrogen atoms that are different from others, or what do you think?
Uh, like I guess the hydrogen are having the same environment.
Which ones can you specify? So all of them, 1, 2, 3, 4, they all have the same chemical environment. That's what you think?
Um, like all of them are bonded to carbon. So
Sure, but what about the other things? Other things around them?
no,
Is it
other
same?
things around are not same.
They're not same. So can you like is it possible to guess which ones are same and which ones are different from each other? I can say this, for instance, that hydrogen 1 and hydrogen 2 have the same chemical environment. Can I not
Yeah.
say that?
Yes.
Actually, they have the same chemical environment because they're both joined to carbon atom, which is joined to Cl atom, and then CH2Br on the other side. On the other hand, I can also say this, that the hydrogen 3 and hydrogen 4 have the same chemical environment.
Yeah.
Do we understand? All right. So in
Yes.
this compound, overall, how many different chemical environments can we see? We can see two
We have
different
two
chemical
different.
environments.
Yeah.
Two different chemical environments. So if that is the case, if I'm having two different chemical environments in my NMR spectrum, how many signal or how many peaks can I expect? I can expect two different signals, okay?
All right.
Two different signals or two different peaks in NMR spectrum. That is, when I say spectrum, I'm talking about the graph that we usually get from the machine. So let's talk about the hydrogen atoms. For example, let's say, so hydrogen 1 and hydrogen 2, okay? Let's talk about them.
All right.
So they're both joined to this carbon, right?
Yes.
And who is the neighbor of this carbon? This carbon is the neighbor. And neighboring carbon has how many hydrogens?
Neighboring carbon has two hydrogens as well.
Two hydrogens. That means, so if I'm trying to do the n+1 formula, here, what can I place in value of n in place of n? I can place 2. Now,
Yeah.
before I couldn't place any value, before I had to place 0, but here I can place a number. Why? Because those two hydrogen atoms, that is hydrogen 3 and hydrogen 4, they don't have the same chemical environment as 1 and 2. They're different. That's why.
Yeah.
They're different, which is why they're said to be non-equivalent, which is why we can consider them in the value of n. Is it fine?
Yeah.
All right. So overall, in 2 plus 1, I'm getting 3, right?
Yes.
Value of n plus 1, I'm getting 3. So if you go to that table and if you check for value of n plus 1 3, you will get a pattern which is a triplet pattern, and the peak will be split in this manner, in this manner. Okay, this is
All
the
right.
type of peak we can expect in the NMR spectrum. All right. Now let's talk about the other two hydrogen atoms, which is hydrogen 3 and and hydrogen 4. For them, so remember now I'm looking at different hydrogen atoms, right? So for
Yeah.
3 and 4, who is the neighbor? For hydrogen 3 and 4, who is the neighbor actually?
The bromine.
Yes. What about the, so we'll specifically look at neighboring hydrogen atoms.
Yeah.
Who is the neighboring atom for 3 and 4? For hydrogen 3 and 4. Who are the neighboring hydrogen atoms? Hydrogen
The
1 and 2, right?
hydrogen one and yeah.
So it's opposite. So when you considered hydrogen 1 and 2, the neighbors were 3 and 4. But now that I'm considering 3 and 4, the neighbors are 1 and 2. Is that fine?
Yes.
And again, so instead of n plus 1, I can put 2 plus 1 again, because we know that 1 and 2 have different environment compared to 3 and 4. So you can consider them. And you'll get 3 again. And so again, this will give you triplet pattern, and
Yeah.
this will also give you triplet pattern.
Yeah.
But I'm going to get two separate triplet patterns, because we know that we're supposed to get two different signals. So if I just show you a rough idea about what the graph could look like, you will get a graph that looks like, so this is one triplet spectrum, you'll get another triplet spectrum. My drawing is not that good, but wait, spectrum is like this. So triplet spectrum looks like this. So in your graph, you will get one like this, all right, and then another
All
one.
right.
You'll get two separate triplet patterns. Is that fine?
Yeah. Yeah.
All right, all right. Also, one more thing. Yes, just sorry about. Um,
Yeah. No
yeah,
problem.
where were we? So we understand that the NMR spectrum will be something like this. And now one more thing that we have to look at is the ratio of the two peaks. When I say ratio of the two peaks, that is the ratio of the heights. For example, Do you expect that both the triplet patterns have the same height, or do you think that one of them will be bigger than the other? So could it be that this one is bigger, like this? So you can see that it's still a triplet pattern, right? But the two triplet
Yeah.
patterns are not same heights, right? One of them, I've intentionally made them larger. Now, the question that we have to answer is, do we expect them to have the same height like this, or do you expect one of them to be bigger than the other? That is what we have to understand. Now, how do you know that? All right, how do you know that? Very easy. Let's say
Yeah.
this triplet pattern is for this one, and this triplet pattern is this one. All right, so two different environments, two different patterns.
Yeah.
Now, when we were considering the hydrogen atoms, what could you check out the number of hydrogen atoms? For example, for example, here, how many hydrogen atoms were responsible for this triplet? Two, right? One and two.
Uh, two
Two
hydrogen
hydrogen
atoms.
atoms. Two hydrogen atoms. So two hydrogen atoms were responsible for this peak. Similarly, for this peak
Yeah.
also, how many hydrogen atoms were responsible?
Two.
Two again. So two again. Now, if you do the ratio, 2 is to 2,
Yeah.
2 is to 2 becomes 1 is to 1, right? Because if you divide 2 by 2, it becomes 1 is to 1.
Yeah.
So here we can be pretty confident that the peaks will have the same height because the number of hydrogens responsible for them were equal in two scenarios. Is that fine?
Yes.
Okay. Um, um, so this will be today's class might be a bit boring to you because I'm just going to keep on giving more and more examples of this. Yeah. So
Yeah. Yeah. No problem.
we won't be looking at anything else today. Like I'll try to do some more examples, and then we'll discuss some examples from the textbook, and then we'll go to the question paper. I've gone through the recent papers from 2020, 21. So there were some NMR related questions from those papers. We will discuss those questions. Also, were you able to go through those questions I gave you before, the ones on organic chemistry? Did you try those? Like there were some homeworks if I'm not
Yeah.
wrong.
Yeah. Like, I tried only one of them, like file one from that whole
All
homework.
right. All right. Okay, so like I gave you some PDFs, right, for organic chemistry, just to refer to. Try to
Yeah.
go
Yeah.
through
Yeah.
those, all right? Try to
Yeah. Yeah.
study those. Right? They're very important. So I'll give you a proper note probably, yeah, soon. But yeah.
All
Anyway,
right.
so here in this compound again, you have a lot of hydrogen atoms. So let's take a closer look at this. So can you tell me whether you think that any hydrogen atoms can be grouped, or there are any similarities in any of them, or what do you think?
Yeah. Like
Like,
all of them have the same chemical environment.
um, are you sure?
No. 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 I guess the middle one, the two of the hydrogen in the middle, they don't.
Yes, that is correct. So let's call them hydrogen one and hydrogen two. All right. So these
Yeah.
two hydrogens, hydrogen one and hydrogen two, they have one type of chemical environment. They have a one type of chemical environment. And the other ones, all right, that means these hydrogen atoms, and these hydrogen atoms, they have another type of chemical environment. And for this group and this group, it's identical because molecule is
All right.
symmetric. So if you look at it from either side, it's same. All right. So these two groups, they
All
have the
right.
same environment. Is that fine?
All right. Yeah.
All right. So in this compound as a whole, how many different chemical environments we can expect or we can see total? Two different chemical environments, right?
Yeah.
And so how many different signals will we get? How many different signals will we get in the NMR spectrum?
Uh, two or three different probably.
Two. It depends on the number of environments. So if you have two different chemical environments, you will get two different peaks or two different signals. All right.
All right.
Okay. So now let's look at specifically the type of peaks. So we know that peaks are not all of same type. They might be singlet,
Yeah.
doublet, triplet. So we have to decide that. So let's look at the blue colored hydrogens, right? So the hydrogen atoms that are
All right.
all labeled in blue colored because they have a specific type of environment. Now consider one of them at first. Okay, so just consider, let's consider this hydrogen at first. Okay, this is one of the blue
All right.
ones, right? It's one of the blue ones.
Yes.
So this is joined to this carbon atom, right?
Yes.
And who is the neighbor to that? This one, the middle carbon.
Yes.
And the neighboring carbon has how many hydrogen?
The neighboring has three hydrogens.
No. Who is the neighbor? The
Like
red
for
colored
the
hydrogen, it's joined to this carbon, right? The carbon that I've underlined red. And who is the
yeah,
neighbor to that? The neighbor is this one,
the
this carbon.
middle carbon. Yeah,
Yes. And the neighbor has how many hydrogen?
two hydrogens.
So in value of n, we will place 2. Okay. We will place 2
Okay.
plus 1. Why are we placing 2? Because those two hydrogen atoms in the middle, do they have same environment or do different environment than the ones that are labeled blue?
They have a different environment.
Different. So they are non-equivalent. So we can consider them. All right. We can take them in
All
our
right.
formula. And how much do we get? 3, right? 3 means
Yes.
what? Triplet pattern. Triplet pattern.
Yeah.
Triplet pattern. All right. Also, one more thing. How many hydrogen atoms overall are responsible for the triplet pattern? Can you guess? So
Uh.
this hydrogen that we're considering, it's the one that is here, right? The one that is red colored, circled in red.
Yes. Yes.
What other hydrogen atoms have the same environment as this?
The
Everybody who's
other
surrounded in
pair
blue
of
color, right? Everybody
yeah,
who's
yeah.
surrounded in blue color, they all have this type of environment. So overall, in
Yes.
total, how many hydrogens will give you this triplet pattern? Total 6.
Yeah.
3 on this side, 3 on that side. They all have the same pattern, same environment, same pattern. Okay, is that fine?
All right. Yeah, yeah, that's fine.
Now let's look at the hydrogens that are in the middle. Okay, the hydrogens that are in the middle. So the hydrogens that are in the middle, again, I have to look at which carbon they are joined to. So this hydrogen and this hydrogen, they're joined to this carbon, right? The carbon in the middle.
Yeah.
And who is the neighbor of this? How many neighbor does it have? It has 2 neighbors, one on that
It
side,
has
one on that side.
yeah.
Yes. So total, how many neighboring hydrogen atoms are there?
Total there are six.
6 neighboring hydrogen atoms. Do we agree? Are we clear?
Yeah, yeah. Yeah, yeah.
So so if I do n plus 1, I'm going to have to do 6 plus 1, and that will give you 7. All right. And
All
for
right.
7, the pattern that is named as septet. Okay, septet.
All right.
And let me just show you that pattern. Again, you don't have to memorize the pattern. If I just want you to show it. Septet pattern. Just a moment. Septet NMR pattern. I think that's an accepted. 1, 2, 3, 4, 5, 6, 7. Yeah, that's accepted. So a septet pattern, we know what a triplet looks like, but a septet looks something like this. This is what septet looks like. Okay. So this
All
in the
right. All
NMR
right.
spectrum, this will be considered as one signal. Okay. This entire thing is one signal, but the one signal has how many smaller peaks? How many smaller or sub peaks total count?
The one signal has two small two smaller peaks.
No, no, overall, all the individual peaks. Add them up. 1, 2,
Oh,
3,
like
4, 5, 6, 7. You see seven lines, seven peaks
Yeah,
inside
there are
the one
seven
corner.
peaks. Yes.
So this septet. Sept means seven, all right?
All right.
Now, if you consider like a graph, if you want to look at like a graph, right?
Yeah.
Then so the graph will have a triplet and a septet, right? One triplet and one septet. So we know what a
Yeah.
triplet looks like. Triplet looks like this. So drop it from here. Triplet looks like that. So you will have a triplet and a septet. Now we have to consider or we have to understand what the height should be. So here, um, for triplet, we know that there are six atoms, right? Six hydrogens, which are responsible
Yeah.
for this triplet. How many hydrogens are responsible for the septet? Like which hydrogen atoms did we actually consider when trying to make this pattern, trying to figure out the septet pattern? The ones that are green colored, right?
Yeah.
In the actual molecule, the hydrogen atoms that are green color circle, those hydrogen atoms
Yeah.
we have considered. How many of them are there actually?
The green colored one or the
Yeah, yeah, yeah.
neighboring one?
The neighbor, not the neighboring ones. When we made
The
this
green
pattern,
color
we
there are two.
considered. Yeah, yeah. So when we figured this out, we considered the green colored ones first, and then looked at their neighbors, right? So now I'm
Yes.
asking you, how many green colored ones are there actually? Two, right?
Yes.
Two. So the ratio of the peaks, the heights will be in the ratio 60 to 2. So actually, what will happen?
Yeah.
The triplet pattern will be bigger, although it's smaller here. Let me just
Yeah.
fix it. I don't know if I can stretch it. Can I? I guess I can. So somewhat like that. And this septet pattern, this will be comparatively way smaller. You will get something like this in your NMR spectrum. And the ratio, what was the ratio? If you look at the numbers, the ratio is 6:1. Do you see here? So triplet is to septet is 6:1.
Yeah.
Do you notice that?
Yes.
So if this height and this height, the ratio of their heights will be 6:2. So if this is 2 centimeters high, this one will be 6 centimeters high. That's how you will actually, you know, like the ratio of the heights will be 2:6:2. Are we understanding this or not?
Yes.
Or 6:2, or if you simplify 6:2, this becomes 3:1, right?
Yeah.
So if this one is 1 centimeter high, this one will be 3 centimeter. This has to be 3 centimeter high. That's the ratio of the heights. Does it make sense?
Yes.
So this is responsible for 2 hydrogen atoms, and this is responsible due to 6 hydrogen atoms. That is how we're going to expect the NMR spectrum to be. Is it clear?
Yes.
Okay. Moving on. More examples. Um, okay. I would like you to go through this, please. Can you look at this structure and tell me what do you think about the number of environments or the number of patterns that we can expect?
I think both of the bromine have the same environment.
Remember, for NMR spectroscopy, we will only consider the hydrogen atoms. That is why this is named proton NMR. We are looking at the protons. Protons are hydrogen atoms.
Oh, oh, all
So
right, all right.
always look at the hydrogens, nobody else. So we have two hydrogens here, and we have two hydrogens here, right?
Yeah.
What do you think about their environments? Do you think they have same environment, different environment, or what?
I guess no, both don't have the same environment.
Why not same?
Like one of the hydrogen like H2 is combined with CH2 and Br, and the other one
And what
is
about
with
the other one?
CH2.
And Br as well.
Uh
So same,
oh
right?
yeah, yeah, yeah.
It's actually
Same,
same
same.
from
Yeah,
both
yeah.
sides. So there will actually be only one type of chemical environment. Yes. So how many signals will we get in our NMR spectroscopy? We will get only one signal, right?
Yeah.
Only one signal. And let's try to consider like the type of signal. So if you consider one of the hydrogen atoms, so let's say you consider one of the hydrogen atoms here, okay? Just consider one of them. If you try to do n plus one, okay? If you try to do n plus one,
Oh,
these hydrogen atoms are they're joined to this carbon, right? This carbon, this one here.
yeah.
Who is the neighbor of this carbon? Neighboring carbon. This one is the neighboring carbon. And how many
Yes.
hydrogens does the neighbor have? How many hydrogen
Um,
atoms does the neighbor have?
the neighbor has two hydrogen atoms.
Yes, but will we take them or will we not consider them?
Uh,
So will we take 0
we will
plus
take.
1 or will we take 2 plus 1? What should we do?
I guess we'll take 2 plus 1.
Nope, we'll take 0 plus 1 because those hydrogen atoms are actually having the same environment as the ones that are on this carbon, which is why they are not, they are equivalent, they're same. So we will not consider them. All right. So
Yeah,
you told me earlier that they have the same chemical environment, right?
yeah,
We can only consider them if they have different chemical environment. Here, they don't have that. They have the same chemical environment. So we will not consider them. So it stays one, which means we'll get singlet, right? So in your NMR spectrum, you will get just one peak. That's it. That's all you'll get. No
or
splitting
all
pattern, no
right, all
nothing.
right.
Is fine.
Can you again explain me that 0 plus 1 part? Like, what should we take 0?
Okay, okay. So consider this previous atom, previous molecule. Okay, let me just look at this here, and then you'll understand. So here,
All right.
so so focus on this part here. This hydrogen, this was the ones that are in the blue color group, right?
Yeah,
And their neighbor was the middle carbon, this middle carbon. Yes or no?
yeah,
So this hydrogen is this hydrogen, which is joined to this carbon, and the neighbor of this carbon is this one. Yes or no?
yes.
The neighbor has how many hydrogens? That neighbor,
Neighbor has two
the
hydrogens.
two hydrogens. So we will take 2 plus 1. Why 2 plus 1? Because those hydrogens are the same environment or different environment than the ones that are in blue color,
Mm, they're different.
which is why we take them, no problem. So you can consider them. Again, look at the green. When we considered them, we considered this hydrogen and this hydrogen, right? And it had
Yeah,
neighbors on both sides, neighbors on the left side, neighbors on the right side. And so in the neighbor, there are 6 carbons, 6 hydrogens total actually. So we can take 6. Why?
all
Because
right.
those 6 hydrogen atoms don't have the same environment as them. They have different environment. So you can take them. That's not a problem. You can consider 6 here.
Yeah,
But if you look at the structure here, all right, when I'm considering this hydrogen here,
yeah,
one of these hydrogens, the neighbor is these hydrogens, but unfortunately they have same environment.
yes.
So you cannot consider them, unfortunately. That's why you have to take 0 here.
All right.
Uh, was it still confusing? Well, I have a few more examples. Maybe next one might be a
No,
bit
no, no.
clearer.
I'm understanding. I'm slowly understanding.
Okay, okay, sure, no problem. Let's look at one more example. Okay, consider this one here. Can you tell me whether you think there can be any groups or any separations or any hydrogens which you think might have same environment or any other ones which have different environment? What do you think?
Um, I guess uh, two of the hydrogen, like
Okay, so let
the
me help
middle
you.
two
So
carbons,
yes, go on. Keep saying.
the middle two carbons have different environment, and the last,
Ones on the
like
side. Yes,
first,
yes. Yeah, that's correct.
first and the last carbon have same environment.
Yes. So these six hydrogen atoms and these six hydrogen atoms, they have the same environment. Whereas these wait, whereas the four hydrogens in the middle, they have one type of environment. Yes.
Yeah,
Okay. So that means overall, how many different chemical environments I can see? Two different chemical environments.
yeah,
And so we will get two separate signals or peaks in the NMR spectrum. Okay.
all right.
Two separate signals or peaks. Now, let's consider any one of them. So we have two groups. So out of the blue, choose one of the hydrogen. Which one? Out of the blue group, choose one. Let's choose this one. Okay. Um, that hydrogen is joined with this carbon, right? The red colored hydrogen, which I've circled, that is joined to the carbon that is underlined. You can see that.
Yeah,
And who is the neighbor to this carbon? The next carbon, right?
yes.
And the neighbor has how many hydrogen?
The neighbor has two hydrogens.
Yes, which are this one and this one, right?
Yeah,
Do these two hydrogen atoms have the same environment as this or different environment as that?
different.
Different. So we can take them. So if you're doing n plus one, you can take them instead of n because they are different. So you will get three, which is corresponding to a triplet pattern. Yes.
All right. Yeah,
So you can expect this pattern here. Okay. Now let's consider. So this type of pattern you will expect from each of the blue colored hydrogen atoms, which is total how many? Six, right?
yes.
Total six atoms. Okay. Now let's consider one of the hydrogen atoms from the green color group. So choose one of them. Can you? Anyone from the green group. Which one do you want to choose? So like
Like
let's
any
choose this one.
carb.
Okay.
All
No,
right.
no, hydrogen always. And proton NMR always check the proton, which is the hydrogen. So
Yeah,
let's
yeah,
choose that hydrogen. So that hydrogen is joined with this carbon, right?
yeah.
And who are the neighbors of this carbon? Who are the neighbors? The neighbors are this carbon and this carbon.
Yes,
So it has two neighbors on two sides. Are we clear on this or not?
yes.
So total, how many neighbors or how many hydrogens are there in the neighboring carbon atoms?
There are one. There's only one neighbor. No, no, two neighbors in that carbon.
Two neighbors. Yes, the central carbon, this carbon to which the hydrogen is joined, it has two carbons, two neighbors. And those two neighbors combined have how many hydrogens?
Like
Can
there
you
will be five hydrogens.
five hydrogen? But will I take
Yeah.
five instead of n, or will I can I not take five? What do you think?
I guess we cannot take.
Yes. So what can we take? Can you tell me?
We will take the less hydrogen one.
No, 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 no.
Like,
Remember, whether we can take or them or we cannot take them depends on whether they're same environment or different environment. We can take them if they're different. So
so we'll take zero.
no, out of the five, right? This hydrogen, and this hydrogen, they have different environment than the one that I've circled in black.
Yeah.
Yes, do we agree or not agree?
Yes.
But this hydrogen and this hydrogen, don't they have the same environment as this one?
Yes.
So remember, we are focusing on this hydrogen here. Now, I cannot take, I can't consider, I cannot considered this, I cannot consider this. Why? Because they have same environment as the one that I've marked.
All right.
But I can consider the three hydrogen atoms on the left neighbor.
Yeah.
So for n plus 1, we'll take 3 plus 1. Do we agree so far? Are we understanding?
Yes.
So you'll get 4, and for 4, you are going to get quartet pattern. So quartet pattern is like this. This is a quartet pattern. A quartet pattern looks like this, all right?
All right.
And how many hydrogen atoms will give you this quartet pattern?
The quartet pattern for four hydrogen atoms.
Yes, the 4 which are in the green color group, right? Remember when we first checked
Yes.
the environment? Yes. So the ratio of the heights will be 6 is to 4. So if I give you like a rough idea about what the graph can look like, you will obviously have this peak.
Yeah.
Okay, wait. You will obviously have this. You will also have this, but the ratio of their heights, it will be 6 is to 4. 6 is to 4. If you
Yeah.
simplify 6 is to 4, I think it becomes 3 is to 2, right?
Yes.
3 is to 2. Okay, so the bigger one is the triplet. So let me make this one bigger. So this is bigger. So this will be like uh, roughly like something like that. So if I give you a simple example of the ratio, so if this one is 2 centimeters in height, this one has to be how long? It has to be 3 centimeters in height,
Yes.
because 6 carbons are responsible for this pattern and 4 hydrogens are responsible for this pattern. Is it fine?
All right.
And if you simplify 6 to 4, you get 3 is to 2. I hope you understood this. If you have any more questions, I can move on. Okay. Just give me one. Oh, so I had a question. Do you have a Facebook account or not?
Facebook?
Yeah, yeah.
Yeah, yeah, I have, I have.
Okay. So the thing is, the class recordings that I'm doing, right?
Yes.
Unfortunately, I can't upload them in my Google Drive because I'm running out of space. Because each recording is like 200 MB, 300 MB. So
Oh, all
like
right, all right.
Google Drive only has 15 gigabytes, so it's like a limited space. I'm running out of space. So what I will be doing is I will upload all of them in a Facebook group. I'll make a group. It will be a private group. I'll invite you, and I'll upload the recordings in there in that group. All right.
All right, all
So
right.
I'll make it in sequel, like in order. So from oldest to the newest recording. So that way, like I can upload them. Otherwise, in Google Drive, I'm running out of space actually. Um, yeah.
All right.
I'll let you know when I'll
Sure,
upload.
sure, sure.
Okay, so this is a cyclic compound, and this is a cycloalkane, and each carbon has 2 hydrogens actually. Here, this one has 2 hydrogen. This one has 2 hydrogen. This one will also be joined with 2 hydrogen atoms. So, what do you think about the hydrogen atoms? Obviously, there are a lot of them. Do you think that they all have the same environment or different chemical environment? What can you think, or what can you say?
Like,
Oh, yeah,
um, I guess they have the same environment.
they have the same environment. Yes, they actually do have the same environment. Now, so if they have the same environment, how many signal do we expect from the in the NMR spectrum or in the NMR graph? In the
Um,
NMR graph, how many peaks do we expect?
I guess we expect probably six. No, no, no. Probably 12 or 13, like that.
No, no, no. No. That's not how we. First of all, you just told me how many chemical environments are there.
There are sorry, six chemical environments.
No, no, no.
Like there are six carbons, so
Yes, there are six carbons, but
all of them are same.
yes. So what I will suggest you to do is consider one of them. Which hydrogen? Let me label them for you. One, two, or not the hydrogen. No, consider the hydrogen. One, two, three, four, five, six, seven, 8, 9, 10, 11, 12. So there's 12 different hydrogen atoms, right? 12 different
Yeah.
hydrogen atoms. Now, what I will suggest you to do is choose one hydrogen. Choose one. Just choose any. Just choose. Don't think about it. Just choose any specific hydrogen atom.
I guess we can choose hydrogen one.
Okay. So you want to choose hydrogen one. So since you have chosen hydrogen one, I'm going to erase hydrogen one. Okay.
All right.
Now in the diagram on the right side, right? I just copied it. So same structure. Choose another carbon. Sorry, choose another hydrogen. Any other hydrogen except one.
We can choose hydrogen number three.
Okay. So I'm going to erase it. Okay.
All
Now
right.
the structures that are left, do they look same to you or do they look different to you? Tell me.
They look
What do you think?
same.
They're same actually. So just need to rotate
Yeah.
one of them. That's it.
Yeah.
Structurally, there are no significant differences, are there?
No.
So you chose hydrogen one and hydrogen three. That means hydrogen one and hydrogen three have same chemical environment. Do we agree or not?
Yeah.
Okay. Now go back and choose two different hydrogen atoms. Two other one, not one and three. Like any other two different. Choose
Uh,
any
two
two.
different.
Just yeah.
I think we can choose hydrogen 11 and hydrogen 12.
Okay. So I'll remove 11 from this one and I'll remove 12 from this one.
All
So
right.
the structures, do they look same to you or do they look different to you?
They look uh same. They look same.
They're exactly same. No structural difference. So that means hydrogen 11 and hydrogen 12, they have the same chemical environment. And you can actually keep doing this the entire day. Whatever two hydrogen atoms you choose, they will always have same chemical environment. That
Yeah.
means in this compound, all 11 or all 12 hydrogen atoms have the same chemical environment. All right or not?
All right.
So all hydrogen atoms have the same chemical environment. That is, their surroundings are the same. No matter which hydrogen or on which carbon, whichever one you choose, it will be same. So since I have only one type of chemical environment, how many signals will we get in the NMR spectrum? We will get only one signal. Remember, the number of signals depends on the number of environments. Okay.
Yeah.
All right. Now, since they have the same environment, just choose any one of them, just to figure out the pattern, splitting pattern. Choose any one. It doesn't matter which one because we know they have the same environment. So we can choose any one and just check. Like let's check 12, all right? No problem. Let's take 12. So
All right.
this hydrogen 12, it is joined to this carbon,
Yes.
and the neighbors are this neighbor and that neighbor, right? It has two neighbors.
Yes.
Neighbors have how many hydrogens total? The neighbors.
Like the neighbor, each of them have two,
No,
so
total,
total
total,
four.
total, total four. But will I take four here or will take zero instead of n?
Uh, I guess we will take uh, zero probability.
Yes, we will take zero because those neighboring hydrogen, that this hydrogen, this hydrogen, this hydrogen, sorry, not that, this hydrogen and this hydrogen, they all have the same environment as this hydrogen, same environment. So we cannot consider them.
Yeah.
All right.
All
Is
right.
that fine or not?
Yeah, yeah, that's fine.
So we're getting one. That means when we get n plus one as one, this is responsible for what pattern? Singlet pattern, right?
Yes.
So you will only get one peak that is singlet pattern. So just one peak. That's it. Are we clear or not clear?
All right. Yeah, yeah,
Okay.
clear.
Okay. Um, there are
All
and
right.
how many different signals we can expect?
I think there are both of them have the same chemical environment.
Wait,
No,
so
there's also hydrogen in OH, so we should
yes,
consider that as well.
yes, we should consider that also.
I think both OH have same chemical environment and CH2 also have same chemical environment,
Yes.
both
So
of them.
so how many types of chemical environments do we have overall?
Four.
No, not four, because the two OH have same environment, and
Yeah.
the two CH2 in the middle, those hydrogens
Oh,
have the same
overall
environment.
two.
Yes. So overall, we are having two different chemical environments. Yes.
Yes.
So we are getting two different chemical environments. So we will get two signals. Two signals. Yes. Okay. So these two hydrogens and these two hydrogens, they will have same signal, and this OH in the hydrogen in the OH and this hydrogen in the OH, they will have same signal. Okay, so let's consider these two hydrogens first. This group and them. If you consider the hydrogen, like consider any one of them, like let's choose only one of them. Let's choose this hydrogen, okay? One of them over here.
All right.
They're joined to this carbon, right?
Yes.
And what are the neighbors of this carbon? Neighbors is, this is one of the neighbor and that is another neighbor, yes?
Yes.
Now, if the neighbor is OH, we will not consider them, okay?
All right.
So out of the other neighbor, how many hydrogen does the other neighbor have?
Like the other neighbor has two hydrogens.
Two hydrogens. But will I take them or will I not take them? Will I consider them or should I not consider them?
I think we should not consider them.
Yes, because they have the same environment
They have the
as these two
same.
hydrogens. Yeah. So this will be one, and that means this will be singlet. All right. Now, so that goes for the red colored group, and what about the green colored group, the OH group? Now, if you have to remember this, for them, n plus one is always zero. Okay, even though they have a neighbor which is different, for OH it's always signaled. Okay, singlet. Okay,
All right.
this is like an exception. So for OH, hydrogen which are inside an OH group, it's always singlet. Okay.
All right.
Okay, so both singlets. Now, for the red color group, how many hydrogen atoms are there? How many hydrogens are responsible for that?
For the red colored group, two hydrogen each of them, like overall four.
Overall, four. So four hydrogens are responsible for this singlet pattern. And how many hydrogens are
Yeah.
responsible for the other singlet pattern?
Two
Two
overall.
hydrogens. So the ratio will be 4 is to 2. Okay. So they will both be
Yeah.
singlets. So that means singlet is very simple. Singlet means you will get one singlet and then another singlet, but the ratio of the area. All right. So if this one is 2, this one will be 4. I think the ratio 2 is to 4, if you simplify it, it becomes 1 is to 2. So like one of them will be double the other. That's
Yeah.
it. One of them will be double the other. Are we understood? Like, do we understand
All
this
right.
much?
Yeah.
Okay. Um, and then we'll look at ethanol. C2H5OH. I want you to do this in your copy. If you have a pen and pencil with you.
Uh, I guess we will consider both of them.
Yeah, but OH we cannot consider. Remember, showed you here. For OH we
Oh,
don't
yeah.
consider as neighbor. So here, how many neighboring hydrogens will we take to? So in that case,
We'll take only one, the
yeah, one neighbor, but
3H.
the neighbor has how many hydrogens? Three, right?
Three, yeah.
So the 3 plus 1, which is 4. So what, quartet? And how many hydrogens responsible for this pattern?
Two hydrogens.
Two hydrogens. Okay. And finally, we have the hydrogen in the OH, and we know that if it's a OH, it's always singlet. So no need to do any calculation. Always singlet. And how many hydrogens in this? Only
Yeah.
one, right?
Yeah.
So this is the rough idea. So if I give you a rough idea about what the graph can look like, um, need a singlet and a triplet if I'm not. We need a triplet and we need a quartet also. Where's quartet?
Yeah.
So the ratio is what? 3 is to 2 is to 1, right? You can check. Triplet
Yes.
is 3, quartet is 2, singlet is 1. So triplet, let's put the triplet first. So let's say the triplet is here, and then you have the quartet, and between the triplet and quartet, who will be bigger? Which peak will be, which signal will be bigger?
Yeah.
Triplet or quartet? Which will be bigger? Check the number of hydrogen that's responsible for that signal, and then we can decide. So triplet is due to 3 hydrogen, quartet is due to 2
Yeah.
hydrogen, and singlet is due to 1 hydrogen. So which one has the most number of hydrogen?
The quartet.
No, quartet is 2. Quartet is response like 2
Oh,
hydrogen.
sorry. Triplet.
Triplet. So triplet peak will be a bit bigger.
Yeah.
Quartet will be a bit smaller, and singlet will be the smallest.
Yeah.
Singlet will be just one peak like this. Okay.
All right. All right.
So do we understand that the quartet will be double the singlet? Quartet has to be double the singlet. Do you agree or not?
Yeah. Yeah. I
Why?
agree.
Why?
Because it's like two.
Yes. So singlet is to quartet, or let me just do it in the ratio of the. So this is triplet, this is quartet, and this is singlet. Triplet was 3 is to 2 is to 1. That will be the ratio in which the size of the area of the peaks are. Is that fine?
Yeah.
Okay. I think we'll look at only one more example and then we're done with this. Uh, C3H7BR. Okay, so C3H7BR. What I want you to do is, um, in your copy, try to draw two possible isomers of this structure. Two isomers. Two possible isomers. If I try to do NMR spectroscopy for both of them, um, what differences can you expect in the NMR spectrum? For example, number of peaks or number of signal. Do you Can you figure out whether they will be different or same? For
So
example,
I guess
for
there will be different environments.
yeah, so
Yes.
for this compound, how many different signals will we expect? Tell me.
Probably three. No, no, sorry.
Okay,
Because
not three. Then
two, I guess.
two. Why two? Tell me.
Because like one carbon has like three hydrogen and the rest of the two has two.
Yes. So the thing is, it's not the number of hydrogen that matters. What matters is the environment. So do you
Oh
expect
yeah,
that?
there's BR. There's BR as well.
Yes. So do you expect two different environments or three different
Be-
environments? We expect three different environments. That is,
yeah.
these hydrogens have one type of environment, this hydrogen and this hydrogen have another type of environment, and this hydrogen have a different type of chemical environment. Okay. And what about this molecule? What do you think? How many different chemical environments do we expect? What do you think? Any idea?
I guess there will be two same environment and one different.
Yes.
So
So
I guess
overall,
two.
how many different? Two different environments. That
Yeah.
is correct. So these hydrogen atoms and these hydrogen atoms, they will have the same environment.
Yeah.
And this hydrogen alone will have a different chemical environment. So that means for this we will get three signals. Yes. And from this compound we will get two signals only. So you can see here how this NMR spectroscopy can be helpful to differentiate between two isomers. Although they have the same molecular formula, chemically they will behave the same way, they'll react similarly, but you can use NMR spectroscopy to differentiate. Does that make sense? Yes, no, hello?
Yes.
Okay. uh, and then where's this? The other day we also looked obviously at these, what do you call this, the values. Remember we looked at this range of values for the
Yeah.
spectroscopy? Let me show you one moment. So something like this we looked at the other day. So these are all the different types of groups, and these are, I think we don't need this and that. So we'll try to use this and try to figure out, for example, the NMR spectrum of an ester, let's say. So let's say CH3, CH2, um, COO, CH3. Okay, so this is an ester. If I drew the display formula for this, it would look something like that. All right, so here, how many
All
different
right.
environments do you see? Tell me. How many different chemical environments are there? Can you figure out?
I guess there are four probably.
Okay, how? So these three have one environment, obviously.
Yeah, they have two like that.
These two have the same environment, and
Yeah.
these three have the same environment. So
Yeah.
total, how many different environments?
Three.
Three different environments. All right. All right. So for the red colored portion, it will be what? Singlet, triplet, duplet. What do we expect? Can you tell me for the red colored
I
ones?
guess it will be uh singlet probably.
No. Who is the neighbor?
Their
How many
neighbor is
neighbor?
the green color
Yes.
one.
How many hydrogen in the neighbor?
Two.
Two. So if I do n plus one, that will be what? Two plus one.
Triplet.
Triplet. So this will be triplet. And if you use this graph here, this table of values here, this entire thing, you can actually figure out the value. For example, how will you figure this out? Um, they will be like, they're all responsible for like alkane, right? They're basically no other extra, functional groups, right? In this part of the molecule, only alkane, like carbon-carbon single bond. Yes. What I'm trying to say is this, what this part of the molecule, it has only alkane. Yes or no? Like carbon-carbon single bond only. Yes or no?
Yeah.
So in the big graph, carbon-carbon single bond, if you check, it's only this one here, alkane. You see here, alkane, carbon-carbon single bond. That is, when your hydrogen is joined to a carbon that is joined to a carbon-carbon single bond, as we see here. Our hydrogen in the red color group, they're joined with this carbon, which is joined with carbon-carbon single bond. Okay.
All
If
right.
that is the case, the chemical shift values can be expected between this range. Okay.
All right.
Between this range, which is from 0 to 1.8, 1.9, something like that.
All right.
So from 0 to 1.8, is it fine? Not zero exactly,
Yeah.
a bit bigger than zero, but around 0 to 0.1.8, something like that. Okay. Uh, and then look at the green color hydrogen atoms. Okay. What do we
All right.
expect? Singlet, duplet, quartet. What do we expect? Tell me. For the green color hydrogen atoms.
For the green colored one, I guess so their neighbor has three hydrogens. So it's 3 plus 1.
Yes, that is 4, right? Which is quartet.
Yeah.
Nice. Now, if I have to figure out the chemical shift values from this graph, so the green color hydrogen atoms, they are joined with carbon, which is joined to CO group. Yes, like there's a
Yes.
CO group here. So
Yes.
our hydrogens are joined with a carbon which has CO group joined. So let's see here. Do you see this? Check this out.
Yes.
So our hydrogen is joined with a carbon which is joined to a CO group, which is an ester specific group. So those hydrogens, the values can be expected between this range, which is, if I look at the graph, somewhere between here. Okay, somewhere between here.
All right.
So between 1.8, so a bit less than 1. So if I draw a line here, so from here till here, from here till here, yes.
Yeah.
So it's like from 1.8 till 3, something like that, we can say. So from 1.8 to 3. Is this fine or not?
Yeah.
All right. And finally, you have the blue colored ones, blue color hydrogen atoms. For them, I think it will be singlet, right? Because there is no neighbor or no nothing. What do you think? The blue colored hydrogen atoms. Don't you think it will be 0? Sorry, it will be 1 because n plus 1 will be 1. N has to be 0 here. Does
Yeah.
that make sense or not? Here, n plus 1 will be equals to 0 plus 1. Because the blue colored hydrogen, do they have any neighbor or do they not have any direct neighbor? Like this carbon has no neighboring hydrogen, right? Like there are no
Yes.
neighboring hydrogen. So 0. Okay. And if I want to figure out the chemical shift values from this graph, so that the part of this that we'll be focusing on is this part. Okay. So our
Yes.
hydrogen is joined with carbon, which is joined to carbon. So here, hydrogen, which is joined with um, carbon, which is joined with oxygen. Here, do you see this? Do you see this here?
Yeah.
Here, your hydrogen is joined with a carbon, which is joined with an oxygen. Isn't that similar to the state here? Here,
Yes.
hydrogen, carbon, with oxygen. So the value here. So if I were to choose the value according to this table, so straight lines from here till here. So from like 3, from a bit higher than 3. So let's say 3.1 to 4.2, maybe 4.3, 4.2, something like that. Do we agree or not?
Yes.
So the values are, remember, these are all approximations. So you don't have to be exactly very accurate in the question paper also. So you can just have a good approximation, 4.2. So these are all chemical shift values. Is that fine?
Yeah.
Okay, so now what does these values actually mean? So obviously we chose these values, right, for each of these type of peaks. So what do these values actually mean? That means when you make a graph, what will we get? We'll get singlet, triplet, and quartet. So singlet, so from 0 to 1.8, what are we getting? 0 to 1.8, what are we getting?
From 0 to 1.8.
Triplet. We're getting a triplet pattern. So
Yeah.
in the graph from 0 to 1.8, you can expect a triplet. Triplet is something like this. So please disregard my rough sketch. It's not as
Yeah. No
accurate.
problem.
Okay.
Yeah. Yeah.
After 0 to 1.8 is this one, right?
Yes.
1.8 to 3. 1.8 to 3, we can expect a quartet, yes? So from
Yes.
1.8 to 3, we can expect a quartet. Quartet looks something like this.
All
Something like
right.
that. Okay? And
All
then
right.
lastly, from 3.1 to 4.2, we can expect what? A singlet. So let's say this is 3.1 and let's say this is 4.2, we can expect a singlet. Okay.
All right.
And if you think about the height of the peaks, all right, so figure out here. So from the structure, the green color hydrogen, there is like two hydrogens are responsible for this, right? Green color. Look at the structure, you can figure. See, in the green color, there's two hydrogen. For red, three hydrogens are responsible for this because here, how many hydrogens in the red color group? Three, yes.
Yeah.
And in the blue color, how many hydrogen? Here, how many hydrogen responsible for that chemical environment? Three hydrogen atoms. So
Yes.
three hydrogen atoms are giving you this pattern. That means if I do the ratio, quartet is 2, triplet is 3, singlet is 3. So it will be the ratio. Obviously, these are the values. These are the value of chemical shift, but my ratio of the height will be um, 3, 3, quartet is 2. So this will be 3, this will be 3, my quartet will be 2. This is the ratio of the areas, okay?
Yeah.
Which means if I fix the areas, this will be a bit taller. Do you understand what's going on here? So
Yes.
the ratio is responsible for the relative areas of the peak. So you can see that the middle peak, which is the quartet, it is a bit smaller because that was responsible for only two hydrogen. Only two hydrogen were responsible for that. So the relative area is a bit smaller. So this is the relative. One more thing, the singlet is not usually like this. Probably could have drawn it a bit better. Something like this. So you can expect something like that. Something like that. Okay.
All right.
All right. So this is for this compound. Is this like understandable? This whole thing, what happened here? So first
Yeah.
we
Yeah.
figured out triplet or triplet or whatever, and then we checked out using this information here what values at what values those chemical shift will be, and in this NMR spectrum in the x-axis, this is your x-axis, right? In the x-axis,
Yes.
values represent chemical shift. Okay, chemical shift. And what does this ratio represent? This ratio represents the relative area of the peaks. Is that fine?
Yeah.
Okay. So finally, we'll just look at two to three examples from your textbooks, from the student book, and then we'll be done for today.
All right.
Probably we'll do the question paper once tomorrow. So I have some examples from the question paper. We'll do those tomorrow. So, okay, am I running out of space here? Okay, unfortunately, I ran out of space. Just a minute. Okay, you can see the blank screen, right? Okay, so this is the one of the questions from your student book only. So just go through this question. I'm giving the graph. So you can see the question.
Yes.
Okay, so let's take a look at this, the type of things that we have. So we are given a few information. Firstly, the compound is C4H8O2. C4H8O2. Now let's look at the values at which the peaks are. So this one is a bit less than 12, right? So like around
Yeah.
11.8, 11.9, something like that. No? This peak, we can guess like the value is at 2.6, 2.7, something like this. 2.6, 2.7. Do we agree or not?
Yes.
And what about this peak? How much chemical shift is that?
That one is 6.
No, no, 6, that is the relative height, but the x-axis value,
Oh,
chemical shift
it's
value.
1. It's
A bit more
probably
than 1, like 1.3, 1.3.
1.2 or 1.3. Yeah.
Okay, so around 1.3. Now, let's look at the values and try to figure out which one could possibly be. So 1.3, 1.3 is like here, right?
Yeah.
Only one. So only this box is available, which means this must be
Yeah.
alkane group. So alkane group. So now, how many? What is the relative height of this? 6, right?
Yes.
Relative area. That means how many hydrogen was responsible for this peak? 6 hydrogen.
Yeah.
Overall, 6 hydrogen. So now 6 hydrogen, that means it's probably something like this: CH3 and then another CH3, right? Something like this.
Yeah.
And they had the same environment. So we know there's two CH3 groups. Two CH3 groups. And and from this graph, does it look like a singlet, doublet, or quartet, or what does this look like? This one. What does this look like? Is it a singlet or doublet or triplet or quartet, or what does it actually look like?
This looks like
A doublet, right?
quartet.
Because
Oh no, no, no,
quartet,
no. Two, yeah,
quartet is only
double.
two lines, so it's doublet. It's doublet. That means n plus 1 must be 2, yes?
Yeah.
That means how much was n? N was 1. So
Yeah.
how many neighboring hydrogen there was? One neighboring hydrogen. Yes or no?
Yes.
That means they were both joined to a carbon which has one hydrogen. Yes or no?
Yes.
Okay. So that is one of the conclusions. And then we have 2.6. So 2.6 in that graph, 2.6 is like here, right?
Yes.
2.6 is here. So let's ignore halogen because we know that there is no halogen in our compound. It's C4H2 is the molecular formula. No halogens is there. It could be
Yeah.
alcohol, could be an alcohol, but could be an ester also, right? Could be alcohol or ester.
Yes.
Now, since how many oxygen there is? Did they tell us how many oxygen in the molecular formula? How many?
Like, you mean how many hydrogen?
Yes. So like 2 point. Um, yeah. So like at 2.6. Sorry, not that. What I meant was in the molecular formula. Molecular formula in the question is C4H8O2, right? I was asking you how many
Yes.
oxygen there is in this. How many oxygen in the molecular formula? They told us
Two.
two oxygen. So it could be COO group, right?
Yeah.
COO group. Now at 2.6 there is no COO group, is there? In this graph, 2.6 there seems
Uh,
to be no COO group.
no, no.
No COO group. But what about hydrogen joined with a carbon that has CO group? So we know that there is high carbon which has CO. There must be something like this. Now, what if I have a neighboring carbon with a hydrogen? That means a hydrogen that is joined with a carbon whose neighbor is a CO group. This could give you a peak. This hydrogen could give you a peak. Now, in this graph, in this table, do you notice this here? Here you have the hydrogen joined with a carbon that is joined with a CO group. Can you notice that? Also, also, what type of peak is this? Singlet, doublet, triplet, quartet? What type of peak is this? What type of peak does it look like? The peak at 2.6. Is it a singlet, doublet?
It's a quartet.
It's a quartet, yes. So that means n plus 1 was 4, yes?
Yeah.
So how much was n? N must have been 3. So how many neighboring carbons there were? How many neighboring carbons there were? Sorry, how many neighboring hydrogens there were? 3 neighboring hydrogens. Yes or no?
Yes.
So that means somewhere there was a hydrogen joined with the CH, and this was joined to a CH3, something like this.
Yes.
And this hydrogen was responsible for this peak, perhaps. Yes or no?
Yeah.
All right. And finally, we have 11.8. So this is what type of peak? Singlet, doublet, triplet, quartet. What type of peak is this? It's a singlet, right?
Yeah.
So n plus 1 must be 1. That means n was how much? N must be 0.
Yeah.
N must be 0. So if n is 0, that means somewhere there was a carbon that has a hydrogen, but the neighboring carbon has no hydrogen. That means the neighboring carbon could have this group, CO group. And if you look at 11.8, at 11.8, there is only one thing. This is this one. Did you notice this? 11.8, there is
Yeah.
nobody else. So there must be COO group. That means, see, this is the CH, this is the CH. So if you think about the structure, if you think about the structure, to singlet, so there must be COOH group. So there must be a COOH group in our compound, COOH group. Okay. And
Yeah.
lastly, we have to have this structure, right? We have to have this structure.
Yes.
So CH, and this must be joined with another CH3, another CH3. Do you understand how we came to this conclusion?
Yeah.
Again, the most important part is that this is present because we have chemical shift at 11.8. That is why you have to understand we have the COOH group, because 11.8 is like here, right? Somewhere here. And at that range, only carboxylic acid group is there. No other groups are there. So you must have carboxylic acid group. And the rest of the part we got from that, from from these two peaks. Is it understandable? Yeah, it's still a bit confusing. I kind of get